Previously, we have seen how structs help us group different pieces of related data together. But sometimes what we really need is a way to represent different possible forms of a single concept. For example, imagine a program that tracks network requests. A request can be either loading, success, or error. Only these three states. Then how do we model that in Rust? We could try using strings like loading, success, or error, but that's error prone. A typo like success without an S will break your logic silently. We need something type safe. Hello everyone, welcome back to the yet another video of the Learning Rust series. An enum, in short for enumeration, is a way to define a custom type whose value is constrained to one of the limited and defined set of possibilities, also called variants. It serves as a type bound because once you define an enum, a variable of that enum type can only hold one of the specified variants, and no other value is possible. In the example we just saw, there can be three possible network states: loading, success, and error. So this is the defined set, and in the program, we can only use value among these variants. If we want to write it in the program, we define like enum request state. Inside braces, we'll define the states: loading, success, error. Now in the main function, to get the state into a variable, we can declare let current state equals request state : loading. So this current state variable is a type of request state and holds the value loading. Now since enum is a special type, to print it we need to derive the debug trait. Hash derive debug. It won't make much sense to you now, just know that since enum is a special data type, to print it we need the debug trait. Now we can write println current state. This is how we print the special type. If you remember, we have seen this before while printing arrays. Finally, the variable current state. Let's run the program. Ignore the warning. It is appearing because we have two unused enums. See the output. Current state is loading. Can I use any other value except these three? Let's try that to see. I'm removing the G from loading. Now if we run, we get an error. Variant or associated item not found in request state. It also suggests that there is a variant with a similar name. If the user makes a typo, it can be checked here. So here, request state can hold only one of these three variants. It's like saying this value can only be one of these specific options. That means no typos, no invalid values, just clean and predictable states. Enums can do more than just list variants. They can store data along with each variant. Let's look at an example. We have a message enum with 4 variants. First is a simple value like we have seen in the previous example. Second is a named field like a struct with 2 fields X and Y. Third is a string value. And fourth is a tuple with 3 values. While using them, we need to provide the specific data type. As you can see in message 1, message 2, message 3 and message 4. Finally, at the end, we have printed them. This is how you can actually print multi-line string. To add a new line, you have to end it with a backslash. Now, when we run the program, you can see the different data types printed for the different messages. So each variant of the enum can have different kinds of data. This makes enums incredibly powerful. Just like struct, enums can also have methods associated with them using an implementation block. Let's define one for our message enum. impl message fn print will take the reference of self as the parameter, print ln message, and we print self. In the main function, we don't need this. We'll just write message4 dot print. Now running it prints the message4, which is the change color. If we call print on the other messages, it will also print the same way. Here, for every type of message, we are just printing it as is. What if we want to print it differently based on the type of the enum? Like for move, we write move to coordinates x and y. And for change color, we want changed color to RGB, then the values. We can achieve this by pattern matching using the match keyword. The match keyword is Rust's way of saying, look at this value and run code depending on which pattern it matches. It's like smarter and safer version of switch in the other languages. We write match self, then inside the curly braces, we write the patterns. First is message quit. We print quit message received. This line means that if self matches with message : quit, then print this message in the console. Then we have message move x, y, print moved to coordinates x and y. For message write, we print text message, then the text. Finally, message change color to RGB. Print change color to RGB. R, G, and B. Here we are just printing all the values. You can perform specific tasks as well, like returning a value or performing multiple lines of code. For multiple lines, you need to write them inside a scope by using the curly braces. Now if we run the program, you can see the print statement varies based on the message type. This is how pattern matching works with enum in Rust using match keyword. Just need to remember one thing while using match. You need to provide all possibilities of the pattern. If you miss one, Rust won't compile the code. Imagine you forgot to cover the message quit pattern. I'm commenting it here to show you. Now if we run it, we get error. It says non-exhaustive patterns. This forces you to think about all possible scenarios. In case you have many other possible patterns remaining, but you don't want to handle them individually, you can use the wildcard pattern. It is denoted by an underscore. And you can just print self here. Now it will run fine. One of Rust's biggest design choices is no null values. Null means no value, but in Rust, a variable that is currently valid and accessible can never exist without a defined and initialized value. Hence, there is no null keyword in Rust. Instead, Rust provides the option enum. It represents either some value or no value safely. Here's how it looks like under the hood. It is the usual enum syntax, except the T inside angular bracket. It is called generic, which we are yet to learn. So for now, simply imagine this enum to be either some value or no value. But how does it help? Let's see with an example. Suppose we have a function getVal, which takes an integer as a parameter. We want it to return the word hi only if the parameter num is above 10. That means the return type should be string. But if the value is below 10, then it won't return anything. In that case, the return type should be a unit type. But beforehand, we don't know the integer value that can be passed to this function. Then what should be the return type? In this case, we can write it to be an option of string. This means that either this function will return a string or will return nothing. So in the function we can write if num greater than 10, return sum of string value hi, else return none. In the main function, we'll declare a variable and call the getVal function with a value more than 10. We know that the function can return one of two possibilities. So we can write match variable sum of val print value is the returned value, or none, where we'll print value is low. Now let's run it. It prints value is high since we passed a value above 10. Now if we make it below 10, it prints value is low. So this is how we can use option to represent a value that might be missing. There are other enums as well provided by Rust, not only just option enum. For example, we also have result enum for error handling. Okay, so we now understand if we want to check from multiple patterns, we can use the match keyword. But sometimes you only care about one specific pattern. Writing a full match can feel verbose. That's where if-let comes in. Here in this example, if we only care about the values above 10, we can get rid of this match block and write if-let sum of val equals t, print value is the returned val. Let's make it above 10 again and then run it. It prints value is high. We can also directly assign value to the variable t using if-let, but we then also need to include an else block to make the conditions exhaustive. One last example I'll show you here. Sometimes you'll need to match on complex or nested enums. You can even add conditions to match arms using pattern guards. For example, in this program, we have an enum for temperature with two scales, Celsius and Fahrenheit. A describe associated function is created inside the implementation block. Then it performs a pattern match on self. First is when the temperature is in Celsius, and then it checks if the value is above 30, then print hot day in Celsius. For any other value in the second line, it prints cool day with the temperature value in Celsius. Similar pattern for the next two lines for Fahrenheit are printed. This is how we perform the pattern guard for this match arm by checking with an if condition. Note, it has been dereferenced the value here, since it is taking from a reference of self. If we run it with a value above 30 for Celsius, we get hot day in Celsius. If we make it below 30 and then run it, we get cool day, 4 degrees Celsius. So to summarize, enums let you define a type that can take one of several variants. Each variant can optionally carry its own data, even of different types. You can attach methods to enum as well, just like struct. The match keyword lets you handle each possible case safely and expressively. The option enum replaces null and forces you to handle missing values. If-let provides a concise syntax for matching just one pattern. You can use match guards for even more control. Together, enums and pattern matching form the core of Rust's expressive type-safe design. Once you understand them, you will start to see them everywhere in the standard library, in crates, and you will feel the need to use it in your own code as well. So that's all for now. Do let me know your thoughts in the comments. Any feedback will help us improve our learning journey. And don't forget to subscribe. Bye for now.